I will start this video to explain you where the formula delta equals F times L divided by AE is coming from. And after that, we will solve an easy problem. So what we know is we know the Hooke law, right? What is the Hooke law? The Hooke law is sigma equal E, the module Joule, times epsilon. So we can deduce that epsilon equals sigma divided by E. Okay. We know for the normal stress, we know the normal stress are sigma equal F divided by A. So if we plug sigma equal F divided by A, we can write that epsilon equal F divided by A times E. Okay, I plug the sigma. And we also know that the little epsilon, so the strain, normal strain, epsilon equal delta L divided by the L initial, let's say L naught. So we can write that delta L, I will make one more steps, delta L equal epsilon times L, or the L naught, the initial L. So if we plug this one, this delta L, we get delta L equal epsilon that I will replace by this formula. So F times A is divided by A times E and times the epsilon L0. That's how we ended up with the general formula, delta equal F times L divided by A times E. And be careful with your units to have everything in correct unit. The little delta will be like a millimeter, and the force will be Newton or kilonewton, L millimeter. The A will be your area millimeter square, and the E, depending if it's F is in Newton, E will be in megapascal. If F is in kilonewton, E will be in gigapascal. So that's how we have this formula. Let's now apply this formula to a simple example. We have, I will move all the way. That's why I keep making it bigger and bigger, is because it's hard to move up and down. Let me go down. So we will do a little examples. We have up something like this. Okay. Let me do that a little bit more round, and it's in a wall. Okay, like attached there. So this is made of the same. Let me try to clean that a little bit. Here we go. This is made of the same material. Let's move that there. So what do we know? We know that the material E equal, let's say, 2.5 gigapascal. This is nylon. We know the force that is applied there. We know that the force equal, let me grab a force, an example, equal 15 kilonewton. Okay, we apply a lot of forces on that rod. Let's see if it's deformed or not. And we have the dimensions of all the different things. So we know this length, 33 millimeter. We know this radius. What is given is the radius, not the diameter. So radius 10 millimeter. We know this length is, let's say, 15 millimeter. Put some random dimension. I need to make sure I have them in front of me. Say 2.5 and 15. And the second radius, this one, let's call that R2, R1, will be 7 millimeter. And the question is, what is D delta? So we have the formula delta, that will be the delta 1 plus the delta 2. So the delta will be delta 1, it will be the force, so the force times the L1 divided by the area of 1 times E, because E the same, and plus the force times L2 divided by A2 plus E. Okay, let's plug that. And if we want, we can write F divided by E. We can factorize and have the L1 divided by A1 plus the L2 divided by A2. I think that's a little bit easier. So delta equal, in our case, the force is 15 kilonewton. E is 2.5 gigapascal. The L1, so we have one that is 33 millimeters, and pi time 10 square, the radius, and the second length is 15 millimeters, and divided by the R2 is 7 millimeters, so pi times 7 square. And when we plug everything, we get the first one. So if we distribute, if you want to check those two, the first one will be 0.63 millimeters, the second one will be 0.585 millimeters, and the total will be 1.215 millimeters. So in total, this rod will elongate of 1.21 millimeter. That sounds good for an island. That sounds small, that's perfect. So that's it for this first problems. I will move that over so we can have everything in your page. Hope that makes sense and that you will remember where the formula delta equal F times L divided by AE is coming from. It's just playing with the equation that you already know. Have a great day. Bye-bye.